Before you take the AI 901 Microsoft Azure AI Fundamentals exam, there is one area you cannot afford to ignore: responsible AI. As AI becomes more powerful, knowing how to build and use it is not enough. You also need to understand how AI can be used safely, fairly, and responsibly. In this complete 6-section study guide, we will cover the key topics you need for the I-901 certification exam, starting with responsible AI principles and how Microsoft approaches ethical AI development. I recommend watching the complete video because each section builds on the previous one, and I have also included a free study guide with the most important exam questions in the description. Stay until the end, because I will also share a simple strategy that can help you prepare more effectively and make it easier to pass your AI 901 certification exam. When we talk about responsible AI, we are not talking about a single software tool or a line of code. Instead, responsible AI is a complete governance framework that guides how we design, build, and deploy AI solutions. Think of it as a set of rules and best practices that organizations follow to ensure their technology benefits society without causing harm. On your exam, you will be tested on your ability to look at a real-world scenario and identify which specific guideline is being applied or violated. Microsoft has organized this framework into exactly 6 core principles. These 6 principles are fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. You will need to memorize these 6 names, but more importantly, you need to deeply understand what each one means in practice. Nearly every AI 901 exam features multiple questions asking you to match a business scenario to one of these exact 6 principles. The first principle we will cover is fairness. Fairness means that an AI system should treat all people equitably and avoid bias that could disadvantage any specific group. For example, if a bank uses an AI model to approve loans, that model must not favor applicants of a certain demographic over others with the exact same financial qualifications. If you see an exam question describing an unequal outcome based on demographic characteristics, the answer is always fairness. To ensure fairness in the real world, developers use a technique called disaggregated evaluation. This simply means testing the AI model on different subgroups of people to verify it performs equally well for everyone. If you encounter a test question about a company checking whether their facial recognition system works accurately across all skin tones, this is a direct example of testing for fairness. The second principle is reliability and safety. This principle dictates that an AI system must perform consistently, safely, and exactly as intended, even under unexpected conditions. Just like a bridge must be built to withstand a severe storm, an AI system must be rigorously tested to handle unusual edge cases without causing harm. If an exam scenario talks about an autonomous vehicle system handling a sensor malfunction safely, it is testing your knowledge of reliability and safety. In the modern era of generative AI, reliability and safety also includes content filtering. When you build an AI application that generates text, you must use safety guardrails to prevent it from producing harmful, violent, or offensive content. An exam tip to remember is that implementing content moderation or blocking malicious prompts is considered a reliability and safety control. Our third principle is privacy and security. This rule ensures that AI systems are designed from the ground up to protect personal data and resist malicious attacks. AI models require massive amounts of data to learn, and it is crucial that this information does not leak out to unauthorized users. A common scenario on the exam involves a chatbot accidentally revealing another customer's private information, which is a clear violation of privacy and security. To uphold privacy and security, developers practice data minimization. This means they only collect the data they absolutely need, and they anonymize or remove personally identifiable information before training the model. If a test question asks why a company removes customer names and phone numbers before feeding data into a new AI tool, you know they're applying the privacy and security principle. The fourth principle is inclusiveness. Inclusiveness means that AI systems should empower and engage everyone, specifically considering people with disabilities and diverse human experiences. Technology should bridge gaps rather than create new barriers. A classic exam scenario for inclusiveness involves adding screen reader compatibility to a mobile app so that visually impaired users can successfully navigate it. You must be very careful not to confuse inclusiveness with fairness on the exam. A major trap many students fall into is treating these two principles as the same thing. Remember that fairness is about preventing biased outcomes and ensuring equal treatment, while inclusiveness is about providing physical or functional access to the technology. If a user simply cannot use the system because it lacks a translation feature or accessibility tool, that is an inclusiveness issue. Our fifth principle is transparency. Transparency means that AI systems should be completely understandable to the people who use them. Users should always be informed about how an AI system makes decisions, what its capabilities are, and most importantly, what its limitations are. People deserve to know when they're interacting with an artificial intelligence rather than a human being. A great example of transparency is publishing a model card. A model card is simply a document that explains exactly what the AI was trained to do and where it might make mistakes. If an exam scenario mentions a company warning its users that a summary tool might occasionally hallucinate or make up false facts, this disclosure is a perfect example of practicing transparency. The final principle is accountability. Accountability dictates that the people who design and deploy AI systems must remain responsible for how those systems operate. AI cannot take the blame for bad decisions. Therefore, organizations must have proper governance, oversight, and review structures in place before putting an AI system into production. The most common way to enforce accountability is through a human-in-the-loop strategy. This means that for high-stakes decisions, a human being must review the AI recommendation before any action is taken. If your exam presents a scenario where a hospital requires a doctor to manually approve an AI medical diagnosis before treating a patient, you should immediately identify this as accountability. Another common exam trap is confusing reliability and safety with accountability. To keep them straight, remember that reliability and safety focuses on the behavior of the software system itself. Accountability focuses on the human ownership and organizational governance behind that system. If a governance board is reviewing a deployment plan, that is a human action, making it an accountability scenario. You should also watch out for questions that try to confuse privacy and security with transparency. Privacy and security is strictly about protecting data and preventing hackers from breaking into the system. Transparency is about explaining how the system works and being honest with your users. Disclosing limitations to your customers in documentation is always transparency, not a privacy control. It is also important to understand that these 6 responsible AI principles apply to all types of artificial intelligence. Whether you are using a traditional machine learning model to forecast sales, or building a highly advanced generative AI agent that writes code, the rules remain exactly the same. The exam expects you to know that these principles are universal across the entire Microsoft Foundry ecosystem. As you prepare for the test, practice reading scenario questions carefully to isolate the core problem. Ask yourself if the issue is about bias, safety, data, access, explanation, or human oversight. Matching the specific problem to the correct keyword will guarantee your success on the responsible AI portion of the exam. Congratulations on completing the first section of this course. I highly encourage you to complete the attached practice test right now while the information is fresh in your mind. Practice questions are the absolute best way to improve your long-term retention and build real exam readiness. The practice test is included with this lesson, so please take advantage of this active learning opportunity. Great job so far, and I am excited to see you in the next section where we will explore foundational AI model concepts. Welcome to the second section of our AI 901 Microsoft Azure AI Fundamentals Certification course. In this lesson, we are going to explore foundational AI model concepts and the different types of AI workloads. Understanding how these models work and how to choose the right workload for a specific business scenario is a critical component of the exam. By the end of this video, you will be able to confidently identify AI model components and configuration parameters. Let us dive in and demystify the core technologies behind artificial intelligence. We will start by examining generative AI models. Generative AI and its fundamentals represent a major shift in how we interact with technology. Unlike traditional machine learning models that simply classify data or predict numbers, generative AI models can create entirely new content. On the exam, you need to understand how these generative AI models actually work under the hood. The most common type of generative model you will encounter is a large language model, or LLM. These models are specifically designed to understand and generate human language. However, organizations must also evaluate small language models, which require less computing power and are more cost-effective. A common exam scenario involves identifying an appropriate AI model based on its capabilities and the specific performance requirements of a business. To understand how these language models process text, you must understand tokenization. When you send text to a model, the system breaks it down into small chunks called tokens. The exam requires you to understand these underlying mechanics to properly evaluate generative AI workloads. Remember that models calculate their processing limits based on the number of tokens, not the number of words. At their core, generative language models operate by predicting the next token in a sequence. When you give the model a prompt, it uses complex mathematics to predict the most probable next token based on the massive datasets it analyzed during training. Understanding this probabilistic nature is an essential AI concept for the exam. Because these models are predicting probabilities, they can sometimes generate information that sounds highly plausible but is completely false. This phenomenon is known as a hallucination. The I-901 exam tests your knowledge of how generative AI workloads operate on Azure, including their limitations. Recognizing when a model is hallucinating is a key skill for ensuring reliability and safety. Once you have chosen a model, you must configure its deployment options and parameters. The most important parameter is temperature, which controls the randomness or creativity of the model's output. A low temperature makes the model's responses more focused and deterministic, while a high temperature makes the responses more varied and creative. The exam expects you to identify appropriate configuration parameters for various scenarios. Another heavily tested configuration concept is the system prompt within Azure AI Foundry. A system prompt defines a model's persona, tone, and operating constraints for the entire conversation. It is applied globally before any user input occurs. Questions on the exam will test whether you can identify the right place to put behavioral instructions, such as telling the model to respond formally or stay on topic. A common trap on the exam is putting these behavioral instructions in the user prompt or in the deployment settings. The wrong answer is placing global rules in the user prompt, as the system prompt is specifically designed to enforce these boundaries. You must firmly grasp this distinction to pass the Foundry implementation portion of the test. Now we must transition to distinguishing between different types of AI workloads. The first major category is traditional machine learning fundamentals. This includes understanding the differences between supervised and unsupervised learning, as well as specific tasks like regression, classification, and clustering. The exam requires conceptual understanding of how these machine learning models learn from data instead of being explicitly programmed. You will be asked to identify which machine learning problem type fits a specific scenario. Regression is used to predict continuous numerical values. Classification is used to categorize data into specific classes. Clustering is used to group similar data points together without predefined labels. Matching the business problem to regression, classification, or clustering is a highly tested skill. The next major workload category is natural language processing, or NLP. NLP concepts support applications that can analyze text and help AI understand and process human language. Key capabilities tested on the exam include sentiment analysis, key phrase extraction, and entity recognition. You must know how to map these capabilities to Azure AI language services. We also have computer vision workloads. The exam module focuses on how computer vision allows applications to decode images and videos. Important capabilities include image classification, object detection, and optical character recognition, or OCR. You will need to know which Azure service implements each of these visual tasks. Speech workloads represent another distinct category on the exam. AI speech concepts include both voice recognition and voice synthesis. Voice recognition converts spoken audio into text, while synthesis generates spoken audio from written text. Identifying the features and capabilities of these speech services is an explicit exam objective. The exam also heavily tests the concept of Foundry agents. Foundry agents are tested at a fundamentals depth, meaning you need to know what an agent is and what tools are available to it. An agent is defined as a persistent assistant equipped with tools, threads, and runs. Tools available to an agent include file search, code interpreter, and function calling. You will be asked to identify when an agent is the right choice over a single chat completion call. While you will not be asked to debug a complex multi-step agent run, you must understand the scenarios where a persistent assistant with tool access provides more value than a basic generative response. This is a major part of the Foundry implementation domain. Finally, you must understand information extraction techniques to derive value from content. The exam tests the difference between Azure Content Understanding and Document Intelligence. Content Understanding handles multimodal sources like documents, images, audio, and video using natural language schemas. In contrast, Document Intelligence excels at processing deterministic forms like invoices and receipts. A common wrong answer on the test is choosing Document Intelligence for a video content extraction scenario. You must choose the right Azure AI service based on the specific business scenario presented. Differentiating between Content Understanding's multimodal capabilities and Document Intelligence's form processing strengths is crucial. As you prepare, practice identifying the right service for different business scenarios. The I-901 validates if you understand these core concepts and which Azure AI services are best suited to solve specific problems. Reviewing the official exam objectives and understanding workload capabilities will ensure you are ready for test day. Congratulations on completing the second section of this course. I highly encourage you to complete the attached practice test right now while the information is fresh in your mind. Practice questions are the absolute best way to improve your long-term retention and build real exam readiness. The practice test is included with this lesson, so please take advantage of this active learning opportunity. Great job so far, and I am excited to see you in the next section where we will explore building generative AI apps and agents in Foundry. Welcome back to Section 3 of our AI 901 Microsoft Azure AI Fundamentals Certification course. In this section, we are moving into hands-on implementation by learning how to build generative AI applications and single-agent solutions using Microsoft Foundry. This is a crucial topic because the I-901 exam heavily emphasizes practical deployment workflows and prompt engineering skills on the Foundry platform. By the end of this lesson, you will understand how to deploy models, structure prompts effectively, and create intelligent agents using both the Foundry portal and SDK. Let us dive right in and start building your practical implementation skills. To get started with generative AI on Azure, you must first become familiar with the Microsoft Foundry portal. The Foundry portal serves as a unified workspace where developers and business professionals can discover models, test ideas, deploy endpoints, and manage AI resources. On the exam, you will be tested on the sequence of steps required to bring a generative AI concept into a working application using this portal interface. The first major step in any Foundry implementation is exploring the model catalog. The model catalog is a centralized repository that brings together foundation models from Microsoft, OpenAI, and other leading industry partners. When reviewing the catalog, you can compare models based on their performance capabilities, context window sizes, supported modalities, and operational costs. Once you select an appropriate foundation model from the catalog, you must deploy it before it can process requests. Deploying a model provisions dedicated or shared compute resources and assigns a unique endpoint URI and API key to your deployment. The exam expects you to know that deployment is a mandatory step before any custom client application or agent can interact with a foundation model. After deploying a model, the best place to test its behavior is inside the Foundry Playground. The Playground is an interactive web interface within the portal that lets you experiment with inputs and parameters without writing custom code. Using the Playground allows you to validate how a model responds to different prompts before building a full software application. While experimenting in the Playground, you will spend a lot of time perfecting your prompt engineering techniques. Prompt engineering is the practice of crafting clear, specific instructions to guide a model toward generating accurate and useful responses. On the I-901 exam, you will encounter scenario questions that test your ability to structure effective prompts for real-world tasks. A fundamental concept in prompt design is distinguishing between system prompts and user prompts. The system prompt sets the overall role, tone, behavioral rules, and constraints for the model across the entire interaction session. For example, A system prompt might instruct the model to behave as a concise customer support representative that speaks only in Spanish. In contrast, a user prompt represents the dynamic input submitted by an end user during a specific conversational turn. While the system prompt establishes persistent boundaries, the user prompt contains the specific question or request to be processed. Confusing these two prompt types is a common exam trap, so always remember that global instructions belong in the system prompt. You will also need to know the difference between zero-shot and few-shot prompting techniques. Zero-shot prompting involves giving the model a direct instruction without providing any completed examples of the desired output. This approach works well for straightforward requests where the model already has strong pre-trained knowledge. Few-shot prompting, on the other hand, includes a few sample input and output pairs directly inside the prompt context. By seeing concrete examples of the expected response format, the model can mirror that structure much more accurately. The exam often presents scenarios where format consistency is required, and few-shot prompting is usually the correct prompt engineering choice. Once you have validated your prompt design in the portal, you can build a lightweight client application using the Foundry Software Development Kit, or SDK. The Foundry SDK provides programming libraries, primarily in Python, that make it easy to connect custom applications to your deployed endpoints. The exam will test your ability to recognize basic code structures that initialize client connections and send completion requests. When writing client code, your application communicates with the deployed model endpoint using standard web protocols like REST endpoints over HTTPS. You supply the API endpoint URL and authentication key, allowing your software to transmit user inputs and receive generated text programmatically. Understanding this basic architecture helps you answer implementation questions about client integration. Beyond single completion calls, Microsoft Foundry allows you to create autonomous AI systems known as agents. A single agent solution in Foundry combines a deployed foundation model with specific instructions, persona settings, and attached capabilities called tools. Creating an agent turns a passive language model into an active assistant that can accomplish multi-step objectives. A key concept to understand for the exam is that you can build single-agent solutions using either a portal-first or a code-first approach. The portal-first approach allows non-developers to configure agent instructions, attach tools, and evaluate behavior visually within the Foundry portal without writing any code. Alternatively, developers can take a code-first approach using the Foundry SDK or REST APIs to create and manage agents programmatically. This flexibility enables teams to seamlessly transition from visual prototyping in the portal to automated software deployment in production code. What elevates an agent beyond a standard chatbot is its ability to perform tool calling. Tools are external capabilities that an agent can invoke, such as searching a knowledge base, executing code, or querying an external database. When an agent determines that it needs external information to answer a request, it uses tool calling to retrieve the data automatically. Testing your single agent solution inside the Foundry playground is an essential step before releasing it to users. In the playground, you can simulate multi-turn conversations, monitor how the agent invokes attached tools, and verify that it adheres to its system instructions under realistic conditions. It is critical on the exam not to confuse deploying a model with creating an agent. Deploying a model simply exposes the raw processing capability of an LLM via an API endpoint. Creating an agent attaches specific instructions, persistence, and tool execution capabilities to that deployed model. By mastering the complete workflow from selecting a model in the catalog to deploying an agent and integrating it into a lightweight client application, you will be fully prepared for the Foundry implementation domain of the exam. Recognizing how these components fit together ensures you can select the correct architectural approach for any given test question. Congratulations on completing the third section of this course. I encourage you to take the attached practice test right now to test your understanding of generative AI apps and agents in Foundry. Completing practice questions is proven to sharpen your recall and significantly boost your confidence for exam day. The practice test is included right here with this lesson, so dive in and practice actively. Excellent progress so far, and I look forward to seeing you in the next section where we will explore building text and speech solutions in Foundry. Welcome to the fourth section of our AI 901 Microsoft Azure AI Fundamentals Certification course. In this module, we transition into building dedicated text and speech solutions using Microsoft Foundry. While generative AI models are powerful, many business applications rely heavily on specific natural language processing, NLP, and speech capabilities to process information efficiently. By the end of this lesson, you will know how to implement text analysis, recognize spoken prompts, and build voice-enabled applications. Let us start with text solutions. In the Azure ecosystem, traditional text processing is largely handled by the Azure AI Language Service. For the exam, you need to understand how to apply common text analysis techniques to solve specific business problems. These techniques include sentiment analysis, language detection, named entity recognition, NER, key phrase extraction, and summarization. Sentiment analysis is a highly tested concept on the I901 exam. This capability evaluates text to determine if the underlying tone is positive, negative, or neutral. If an exam scenario asks how a company can automatically monitor customer product reviews to flag unhappy customers for immediate follow-up, the correct Azure AI capability is sentiment analysis. Another critical capability is named entity recognition, or NER. NER scans unstructured text and identifies specific entities, such as people, organizations, locations, or dates. A related and equally important feature is PII, personally identifiable information, detection, which locates sensitive data like phone numbers or social security numbers so that they can be safely redacted. Key phrase extraction and text summarization are designed to help users digest large amounts of information quickly. Key phrase extraction pulls out the main talking points or keywords from a document, while summarization generates a condensed version of the original text while preserving its core meaning. The exam will test your ability to differentiate between pulling exact keywords versus generating a brand new summary. In Microsoft Foundry, you can build lightweight applications that incorporate these text analysis features. Using the Foundry SDK, you can integrate text analytics directly into your Python client applications to process user inputs before they're ever sent to a large language model. This hybrid approach is common in enterprise solutions. Moving beyond text, the AI 901 exam strongly emphasizes speech solutions. Azure AI Speech enables applications to understand and generate human speech, which is fundamental for accessibility and natural user interfaces. The two primary concepts you must know are speech recognition and speech synthesis. Speech recognition, commonly referred to as speech-to-text, STT, is the process of converting spoken audio into written text. This is the engine behind real-time transcription, meeting captions, and voice command systems. If a scenario involves taking a live audio feed and turning it into a text document, you are dealing with a speech-to-text workload. Conversely, speech synthesis, or text-to-speech, TTS, converts written text into spoken audio. Azure provides incredibly lifelike neural voices that can read text aloud in multiple languages and emotional tones. A classic exam question will ask you to identify the service required to read a generated news article out loud to a visually impaired user. The answer is text-to-speech. Modern generative AI introduces a new paradigm for speech workloads, multimodal models. The I901 exam specifically tests your knowledge of how a deployed multimodal model can natively respond to spoken prompts. Unlike older systems that require a separate STT step before sending text to the model, multimodal models can process the raw audio directly as part of the prompt. Despite the power of native multimodal models, there are many scenarios where you still need dedicated Azure speech tools. Microsoft Foundry tools allow you to integrate Azure Speech directly into your agentic AI workflows. The exam requires you to know how to build a lightweight application using Azure Speech within Foundry tools. When building voice-enabled AI agents, you combine these capabilities. An agent can use speech-to-text to hear the user's request, process the intent using a language model, and then use text-to-speech to speak the response back to the user. Understanding this sequential workflow is key to passing the implementation domain. The exam also expects you to be familiar with the Azure Speech SDK fundamentals. Just like the text-based Foundry SDK, the Speech SDK is heavily tested in the context of Python coding syntax. You will be asked to read and understand basic code snippets that initialize a speech configuration, set the language, and trigger recognition. A common trap on the exam is confusing when to use a simple text translation service versus a speech-to-text service. Always pay close attention to the input format described in the question. If the input is an MP3 or a microphone feed, you must involve a speech recognition capability before you can analyze the text. Real-time transcription is another vital scenario covered on the AI. 901. Azure handles continuous real-time audio streams differently than batch processing pre-recorded audio files. The exam will validate if you know how speech AI is deployed across industries like healthcare and retail for live interactions. Furthermore, you should understand how to configure language detection within your speech solutions. If your application receives spoken audio but does not know the user's language in advance, Azure Speech can automatically detect the spoken language before transcribing it. As you study the Foundry portal, pay attention to where text and speech features intersect with prompt engineering. Sometimes, the system prompt must explicitly instruct the model on how to format its text output so that the downstream text-to-speech synthesizer pauses naturally or emphasizes the correct words. Because the implementation domain makes up 55 to 60% of the I-901 exam, you must be comfortable with the practical steps required to deploy these solutions. Remember that you need an API endpoint and a key to authenticate your lightweight client applications to Azure AI language and speech services. To master this domain, focus on mapping the correct Azure service, whether it is sentiment analysis, NER, STT, or TTS, to the specific business problem presented in the scenario. Practice reading basic Python snippets to ensure you can identify how these services are invoked using the SDK. Congratulations on completing Section 4. I highly encourage you to tackle the practice test included with this lesson to validate your understanding of text and speech workloads. Testing yourself now will cement your knowledge of the Azure Speech SDK and NLP concepts. Great work, and I will see you in the next section where we will explore computer vision and image generation in Foundry. Welcome to the fifth section of our AI 901 Microsoft Azure AI Fundamentals Certification course. In this module, we dive into visual AI capabilities by exploring computer vision workloads and image generation within Microsoft Foundry. As visual processing becomes a core pillar of modern cloud applications, understanding how Azure interprets existing imagery and creates new visual content is vital for your success. By the end of this lesson, you will be able to distinguish between traditional computer vision tasks, modern multimodal visual analysis, and generative image workloads. To understand visual AI on Azure, we must first look at traditional computer vision capabilities. Traditional computer vision solutions use specialized machine learning models to decode images and videos into structured data. On the exam, you will need to recognize specific visual tasks such as image classification, object detection, and optical character recognition, OCR. Image classification is a foundational task that involves assigning a single label or category to an entire image. For example, if a system scans a photo and determines whether it contains an indoor or outdoor setting, it is performing image classification. Object detection goes a step further by not only identifying what objects are present in an image, but also pinpointing their exact locations using bounding boxes. A heavily tested exam scenario for object detection involves an automated manufacturing line scanning products to locate and count structural defects. Optical character recognition, or OCR, is another essential feature. OCR extracts printed or handwritten text from images, documents, or signs, converting it into searchable and editable digital text. If an exam question describes a mobile app that scans business cards or street signs to capture text, OCR is the correct Azure capability. In contrast to traditional computer vision services, modern generative AI introduces multimodal foundation models that can natively analyze visual inputs. Instead of requiring a dedicated pre-built vision model for every specific task, a multimodal model can accept an image directly inside the prompt alongside text. This multimodal capability allows you to ask open-ended questions about an image, such as asking the model to describe what is happening in a photo, explain a complex diagram, or translate text found within a picture. The I-901 exam tests your understanding of when to use these native multimodal capabilities versus traditional computer vision APIs. Moving from interpreting images to creating them, we encounter generative image workloads. Microsoft Foundry provides access to state-of-the-art generative image models that can produce brand new visuals from text prompts, a process often referred to as text-to-image generation. When building applications with generative image models, you must carefully consider responsible AI principles, specifically reliability, safety, and transparency. Because image generators can be misused, Azure implements strict content filters and safety guardrails to block the creation of harmful, inappropriate, or copyrighted imagery. Furthermore, transparency in generative image applications often involves content provenance and labeling. The exam expects you to understand that organizations deploying generative visual tools should clearly disclose to users that the images were artificially generated by an AI model. Within the Microsoft Foundry portal, you can experiment with image generation models in the playground just like you do with language models. You can test different prompt styles, such as adjusting descriptive adjectives, art styles, or compositional instructions, to see how variations affect the final generated output. When integrating image generation or computer vision features into lightweight client applications, you will use the Foundry SDK or corresponding REST API endpoints. Your application transmits the image or the text prompt securely to the Azure endpoint, which then returns the analysis data or the generated image asset. A common trap on the exam is confusing object detection with image classification. Remember that classification tells you what is in the image overall, while object detection tells you where every specific object is located using bounding boxes. Keep this distinction clear to secure easy points on visual workloads. Another critical distinction is knowing when to use custom computer vision training versus utilizing pre-built foundation models. If an enterprise needs to recognize highly specific or proprietary items, like unique factory components, they typically use custom vision training, whereas general scenes can be handled by pre-built multimodal models. As you review the computer vision domain, make sure you can map each visual task, classification, object detection, OCR, multimodal analysis, and image generation, to its correct business scenario. Scenario-based questions on the I-901 will frequently test your ability to match the right tool to the visual requirement. The implementation portion of the exam will also check your familiarity with how image data is passed in client code snippets. Reviewing basic Python syntax involving multimodal message payloads will ensure you are comfortable reading code blocks on the test. Remember that visual AI solutions often work in tandem with text and speech workflows. For instance, an agentic application might use computer vision to analyze a photo uploaded by a user, and then use text generation to write a detailed product description based on that visual analysis. Take time to explore the documentation and tutorials available inside the Microsoft Foundry portal regarding visual models. Getting comfortable with the visual capabilities in the playground builds the practical intuition required for the exam's scenario-based questions. Master the definitions, differentiate between pre-built services and generative models, and always keep safety and compliance top of mind when evaluating image solutions. You are making fantastic progress through the course content. Congratulations on completing Section 5. I strongly encourage you to take the attached practice test right now to reinforce your understanding of computer vision and image generation. Testing yourself immediately locks in your knowledge and prepares you for the final section. Great job, and I will see you in the sixth and final section where we will explore information extraction using Azure Content Understanding. Welcome to the final section of our AI 901 Microsoft Azure AI Fundamentals Certification course. In this concluding lesson, we explore Azure Content Understanding within Microsoft Foundry tools to extract structured data from unstructured sources. As organizations ingest massive amounts of diverse files, being able to reliably process and structure this data is a key skill tested on the exam. By the end of this lesson, you will know how to extract schema-based information from multimodal content to power intelligent applications. Modern enterprises are flooded with unstructured data, including PDF documents, images, audio recordings, and video files. Traditional parsing methods often require complex custom code and rigid templates. Azure Content Understanding streamlines this process by leveraging generative AI models deployed in Microsoft Foundry to ingest and reason over multiple content types. A core concept you must understand for the exam is the role of analyzers in Azure Content Understanding. An analyzer is the configuration component that dictates how incoming content is processed, defining your extraction settings and schema fields. You can utilize pre-built analyzers for common tasks, such as processing invoices or procurement documents, or build custom analyzers tailored to your specific enterprise requirements. Azure Content Understanding stands out because of its true multimodal ingestion capabilities. Unlike traditional document processing tools that are restricted to text or flat forms, Content Understanding can natively process documents, images, audio, and video files under a unified framework. This makes it an ideal back-end service for complex agentic workflows and search implementations. When configuring field extraction, Content Understanding allows you to define a schema to capture specific values without requiring complex prompt engineering. The underlying language models parse the content, extract the requested data fields, and provide confidence scores for each extracted value. These confidence scores ensure data quality and minimize the need for manual human review. Another vital feature emphasized on the exam is layout analysis and OCR integration. Content Understanding automatically performs optical character recognition, detects structural layout elements like paragraphs, tables, and section headings, and normalizes messy files into clean, structured outputs. For developers building lightweight client solutions, Azure Content Understanding integrates directly into the Microsoft Foundry ecosystem. You can deploy required foundation models directly within your Foundry portal and map them to your content analyzers. When writing code via the SDK, your application sends unstructured files to the Content Understanding endpoint. The service processes the asset using your specified analyzer and returns structured metadata, key-value pairs, and customized schema representations that can easily feed into downstream retrieval augmented generation, RAG, pipelines or AI agents. A frequent trap on the I-901 exam is confusing Azure Content Understanding with traditional document intelligence. Remember that while document intelligence excels at rigid, highly structured form processing, Azure Content Understanding is designed for advanced multimodal reasoning across diverse unstructured files, including audio and video streams. As you prepare for the exam questions on information extraction, always look for clues regarding the input file type. If the scenario mentions extracting data from multi-format sources like videos, mixed documents, and audio logs, Content Understanding is the correct architecture to choose. Reviewing the integration patterns between Microsoft Foundry and Content Understanding will give you a distinct advantage on the practical implementation domain. Make sure you understand how model deployments anchor the intelligence behind custom and pre-built analyzers. Building upon our exploration of Azure Content Understanding, Paragraph 12 emphasizes the importance of schema governance when scaling your extraction pipelines across enterprise divisions. Establishing standardized field definitions ensures consistency whether your organization is processing financial logs, customer support transcripts, or compliance videos. Paragraph 13 highlights the role of confidence scoring mechanisms within content understanding tools, which allow automated systems to flag ambiguous extractions for manual verification. This automated triage protects downstream applications from ingesting corrupted or low-quality data attributes. In paragraph 14, we look at how integrated OCR and layout parsing work concurrently to retain structural hierarchies from complex multi-page PDF documents. Preserving tables, footnotes, and header relationships is critical for maintaining context during automated data ingestion. Paragraph 15 details the security and authentication parameters required when connecting client applications to your custom content analyzers via the Foundry SDK. Ensuring proper role-based access control prevents unauthorized exposure of sensitive unstructured source files. Paragraph 16 bridges information extraction directly into retrieval-augmented generation workflows, demonstrating how extracted text and structured metadata feed vector databases to improve enterprise chat accuracy. Cleanly structured extraction directly translates to better contextual grounding for agents. With this comprehensive coverage, you have completed the entire breadth of the I-901 curriculum, moving from foundational concepts through responsible AI, natural language processing, speech, computer vision, generative AI, Microsoft Foundry, and content understanding. To cement your mastery of these domains, be sure to complete the final comprehensive practice exam included with this course. Reviewing your weak spots and practicing scenario-based questions will ensure you walk into the test center or online proctored exam with absolute confidence. This is a final reminder to keep focusing on practical scenario mapping and architectural trade-offs, ensuring you can distinguish between related services like content understanding and document intelligence under exam conditions. Thank you for joining this certification journey. I wish you the absolute best of luck on your AI 901 exam and in your continued exploration of cloud-based artificial intelligence with Microsoft Azure.